Hi, this is Thomas from ABX Game Tools. In this video we're going to look at the speed component that you use to set the various speed settings of a unit. In particular we're going to see what changes have been made between previous versions and ABX Path 2.0. So let's have a look. As you can see, we have the humanoid speed component. This is what we've had as the default speed component in ABX Path since the beginning. And it has changed somewhat in ABX Path 2.0, and we've also made some changes to how you interact with it. So let's start to just look at the different properties. As you can see, the second half of this component looks the same as it did before. So we have the different speed settings that you could set on the component, and those are the same as they've been always. Now the top part is different. As you can see, we have two new areas. We have rotation. This controls how the unit rotates when it needs to change its direction. It has an acceleration max, so that how fast does it actually reach its turn speed, and then it has an actual turn speed. Similarly, we have the same for movement. We have acceleration, max acceleration, so how fast will the unit actually approach its preferred speed, and the same here, how fast can it actually break down to come to a stop. Then we have a minimum speed, which defines how low the unit, or how slow it can move before it actually stops. And also has a maximum speed setting, which is hidden in this case because we are actually using the run speed as the maximum speed, but if you use or create your own speed components, you would also have that here. So before we actually look into how you actually control units and how you set their speed and what is different from previous versions, let's look at this, what this has to do with movement and how the unit moves. This is quite different from previous versions, so we'll just have a look at the movement part. The same will then apply to rotation. So let's start the scene. We have just for this a single unit in here, and I'm just going to put it on the other side of this obstacle, and we'll just have a look at how the unit actually follows its path. And as you can see, it follows it quite strictly. It turns instantly, or it changes its velocity quite fast towards the new one, so it follows the line very closely. So let's try and change these values a little bit so that you can see the effect it has. So if I reduce the acceleration, let's say it can only accelerate by 5, and then we'll also set the walk speed a little higher so that it actually tries to get to a higher speed. And then we'll just try the exact same thing. I'm just going to put the unit over here, and now as you can see, it will actually have a more curved movement. It will not be very precise in its path. It will curve around quite a bit. So basically this allows you to get your units to move the exact way you want. If you want them to have a strict path, then you can just make sure that you have an acceleration that actually matches your maximum speed. So just play around with that. Alright, so let's move on and look at how you can actually interact with units and how to set their speed. So we're just going to clean this up a little bit because we don't need this anymore. Now in label these. So in previous versions of ABX Path, and also now, one way to interact with the humanoid speed component is to actually call some specific methods that are available in that. You have a crawl method, a walk and a run method, and so forth that you could use to control the speed of the unit. Now the downside to that is that you would need to get a reference of the actual humanoid speed component and then call the methods on there for each of the units to change their speed. Now this isn't super flexible, so we've made some changes. However, you can still do this. We have not changed the way the humanoid speed component works in order not to break too many things. So you can still use the old method if you want, but you also have now the option to use a new method. So let's just have a look at this scene now. Once I've enabled these new things, as you can see, we have 3 sets of units. We have an AI group over here. We have a selectable group in here. And then we have a solo unit just patrolling over there. And as you can see, we have 4 buttons to change the speed of the 3 groups, and then one to change the speed for all. So basically when I do that, as you can see, these will start to move faster. And the same goes for the other buttons. So how do we do this? Well, the reason we have these 3 different groups is that we have 3 different options of doing this. So let's look at some code to see how that is done. Now, I have this unit handle that does all this, and the first thing it does is it creates this AI group. Now, there are a few things in here that have already been covered in other videos, but we'll just cover them in a little detail, but not too much. So basically, the AI group is created using, in this case, the default transient unit group. You could have created your own, but in this case, we'll just explicitly instantiate a group and then add members to that group. Another way to do this, again, a more flexible way, would be to actually use the grouping strategy that you've set up to how you want your groups created when you have a number of units that you want to add. But for this, we just assume that all the units that we have in this group are the same. They have the same. They want the same speed settings and so forth. So next up, we have this logic that draws the buttons and, more importantly, executes some logic when the buttons are pressed. So for the first one here, to change the AI speed, well, we simply call set preferred speed on our group. That's it. Next up, we have unit selection. The way you get a hold of the units, selected units, is the same as it has been before, like this. However, the return value of this selected property is quite different from what it was. This is now an I grouping, which is basically, or at least potentially, a group of groups of units. This enables you to create more advanced groups, so that when you select stuff, it may actually end up creating multiple groups because they have different settings. Like they have different speed settings, they have different capabilities to scale stuff or fly or whatever. But I mean, you don't really have to worry about this for the purpose of setting a speed, because as you can see, you simply just call set preferred speed again on the grouping. Easy peasy. Next up, you have solo units. As you've probably seen in previous videos, the way to interface to units changed quite a bit. So now you simply get a hold of the unit facade for the unit, and using that you can access various things on the unit, tell them to move and so forth, and you can also simply set their preferred speed, again using this method. And finally, we have the option to set the speed for all the different units. I've just extracted that out to a method here. So what we could do, as you can see, I'm starting to get with just getting a reference to all the units referenced or registered in the scene. Now I could just loop over through this list and just set the speed of each of the individual units. But due to the fact that, well, in Apex Path that would work just fine, but in other packages such as Apex Steer it would not, because it actually has a little more advanced logic when it comes to groups. So the best way to actually change the speed setting is to change it on the group if there is one, and otherwise you can obviously just change it on the unit itself. And that's what this logic does. As you can see, if the unit does not have a group, it will just set it on the unit. If it does have a group and the group has not yet been processed, it will then set the speed of the group. And that's basically it. So, one more thing we're going to look at for this video is making your own speed components. So as you can see, I've created another speed component here, a simpler version. It derives from this new class called speed component. So this lets you create your own speed components, and you will get these rotation and movement acceleration settings for free. They will just be there, and then you can just add your own properties that you need to control your particular speed component. So I've actually put this on this solo speed, this solo unit. As you can see, we have this generic speed component, and it just has this additional default speed property that will control how it starts out, the speed at which it starts out. And that's basically it. It has a number of methods that you can override. You should, in most cases, override this clone from, so that if it needs to be cloned, it will actually know how to clone and copy the relevant property values or field values across to the other speed component. One more thing that you could override, which would probably be what you would most often do, is this get preferred speed. Now this is where, when people or other components need to know what the unit would like to move at, the speed it would like to move at, they will call this method. So the default is simply that it will return this preferred speed. So if you need some additional logic to control when this preferred speed is actually available, you can put it in here. For instance, in humanoid speed component, it has some logic in place to cap the speed if the unit is strafing, or if it is actually moving backwards. It will cap the speed to other values. So it cannot move forward, or rather it cannot move backwards as fast as it can move forwards. Well, depending on the settings, of course. So you could basically, for instance, if you wanted to make a car speed component, let's say, well, cars, they tend to not be able to move sideways, so basically you could add that in here, so that if it actually is or tries to change its direction radically, it would not be able to actually move that direction until it has actually turned to face the direction. Yep, so that's all there is to it. Hope that makes sense, so see you in the next video.